Hello everyone. After we learn how to do the interval estimation for the two population, now another way we can use to say the difference between the two population is by hypothesis testing. So here we would like to introduce the hypothesis test about two population when the population mean sigma 1 and sigma 2 they are known condition. Okay, so just like what we had ever introduced in one population or one group condition, hypothesis test about the two different populations, they can be expressed just like the difference of the mean. They may larger or equal to a specific value or less or equal to a specific value or equal to a specific value. So here you will find if the new hypothesis and the alternative hypothesis they are equal or less, okay, we will say they are one tail test and they may lower tail or upper tail. So if you would like to know what is the lower tail or upper tail, please notice the expression from the alternative hypothesis. If this is less, okay, it means lower tail. If it's larger, we will say it's upper tail. Because if we express them in the curve, okay, in the normal distribution curve, just like this one, okay, you will find because you were larger than a specific value, okay, so it is larger than what's a specific value, okay, so we will say it's a upper tail case, okay. But if we express that in a normal distribution curve but it is less, okay, less than a specific value, okay, that means it will lower than a specific value, we will say it's a lower tail case. So it depends on the express from alternative hypothesis. And the two tail case, that means because it's not larger or less, okay, it's equal to a specific one, so it's not, yeah, we will express them, that means they will not larger or less, okay, than a specific condition. Only in such condition it will fit what it would like to express. So we will say it's a two tail test case condition here, okay. So when the sample size they are larger enough, okay, just what we had ever introduced, we can describe a normal distribution, okay, we can describe it as a normal distribution. And then in such conditions we would say, okay, the difference between the two population mean we will express its test statistic is z because it follows the normal distribution curve, okay. So in such conditions you will also find we will use z to express it, and based on the S1 bar minus S2 bar, okay, the difference and minus a specific value from your hypothesis, and then divided by the standard error of the S1 bar minus S2 bar, okay. It's a test statistic for you to do the hypothesis test. So here we can back to our example questions here. To evaluate the difference in education quality between the two training centers, so we can use mu1 as a mean of the examination score for the population of the student they get trained in center A, and we can use mu2 as a mean of the examination score for the population of individual they train at the center B, okay. So here you will find the population standard deviation from center A is 10, from center B also 10, Okay, and the level of significance alpha is 0.05, and the sample size, one is 30, the other is 40, and the sample mean, that is the mean of the score in those two centers. One is 82, the other is 78. So does the data suggest a significance between the two population mean at the two training centers? Which one will be better? Okay, you can do the hypothesis test. So follow the steps we learned before to do the hypothesis test. The first one, okay, remember, is to develop the hypothesis. So based on the questions you would like to know is the difference, okay, the two training centers, will they have significant difference, okay, between them? Okay, so here we can do the hypothesis is the new hypothesis and the alternative hypothesis. They can express like this. That is mu1 minus mu2. They will equals to 0. That means the two centers, okay, they don't have significant difference, okay, between them for the training. And mu1 minus mu2, they may not equal to 0. That means they may have some difference. But when you find it's equal and unequal condition, it's a two-tailed test case, okay? So you have to know when you calculate the p-value, you have to double it, okay? Because you have two tail here. And the second step is to specify the level of significance. It's based on the questions expressed in your questions. It tell you the alpha is 0.05. Okay, so the third step is to compute the test statistic. So follow the formula you learn for the z, okay, because it's a normal distribution condition. So based on the formula you learn, then you can calculate out the z-value is 1.66. Now the fourth step, okay, if you would like to use the p-value approach, then you have to compute the p-value for the two-tailed test. So the first one you can use is to calculate out the upper tail the result first. Then because the curve is symmetric one, so you can double it for the final result. Okay, when you check the z-value and its probability from the z-value table, you will find the z-value is 1.66. Okay, and the area to the left of z, okay, it will be 0.9550. So you can use 1 minus 0.9550 to get the upper tail probability. That means because the z-value table is a cumulative condition, so that means till here, okay, all the probability is 0.9550, and you will know total probability is 1. So in such part, that means, okay, you have to use 1 minus 0.9550, okay, to get the part of it. Then because it's a two-tail case, okay, so you get the probability from this part, you can double it for this part, okay, to get the final result. So the total p-value is 0.097. Okay, then the next step is determine whether you will reject the new hypothesis or not. So based on the rejection rule you learn, if the p-value is less than alpha, okay, you can reject the new hypothesis. Today you get, okay, you get the result that is p-value is 0.97, okay, and its alpha is 0.05. So you will find the p-value is larger than the alpha, so we do not reject the new hypothesis. Okay, we do not reject the null hypothesis. So we will do the conclusion. That is, the sample result do not provide significance to conclude the two training centers have different quality, because the null hypothesis say the difference between them, they are equal. Okay, mu1 minus mu2 are equal to 0, and you cannot reject such expression. So that means the difference between the two centers, their difference is not so significant. Okay, based on the statistic analysis, so you can do such conclusion, and that's the hypothesis test for you. Okay, and then you can also use critical value approach. That is, if you use the alpha that is 0.05, okay, because it's a two-tailed case, so the z value for the alpha, you have to divide the alpha, okay, by 2, because that means the probability here and the probability here, the two parts, okay, they are be 1 and 2 totally will equal to alpha. So here you will find you need to divide it alpha by 2, okay, in order to express in such condition that in the alpha should the z value should be larger or less than a specific condition. So you have to use half alpha for the z value. So here is 1.96. So you can express then that the rejection rule for it is z value that is less or equal to negative 1.96 or larger than 1.96. So today you calculate out your z value is 1.66. Okay, it's not larger or less than some specific z value, so we do not reject the null hypothesis. So here we will do the conclusion, that is, we do not provide the sufficient evidence to conclude the two training centers, they have different training quality. Okay, so that's for today's learning. Thank you.